Welcome to Chemistry Made Simple. Today we are going to begin with another tutorial. This is a new section because we are going to deal with a new topic: redox reaction. Here we are going to discuss the actual meaning, the processes that takes place in redox reaction, so that I'll be able to understand whatsoever thing that happens and then how to solve problems under redox reaction. Now, I have already introduced the topic, which is redox reaction. In redox reaction, what do we look for, or what do we look out to? We look out to two processes. We look out to one, oxidation processes, and then we also look out to reduction processes. So, in fact, we are going to look at oxidation reaction, and then we are going to look at reduction reaction. Oxidation and the reduction reaction are complementary processes under redox reaction. Oxidation reaction and then reduction reaction are complementary processes. So oxidation reaction and then reduction reactions are complementary processes. What does it mean? Which means oxidation and reduction reaction occur simultaneously in a reaction. Which means oxidation reaction and reduction reaction occur simultaneously. Now that is what happens in redox reaction. Therefore, it is the total change. So when oxidation reaction and the reduction reaction had occurred simultaneously, it is the effect or the result of the total change that we refer to as redox. So therefore, the total change is referred to as redox. Somebody may simply ask, then explain redox reaction. So we have our definition on the board. What is redox reaction? Redox reaction is a reaction in which oxidation reaction and then reduction reaction occur simultaneously, resulting in change in oxidation numbers of the elements. So we are going to look at a reaction where oxidation reaction takes place and then reduction reaction takes place, resulting in a certain change in oxidation numbers. Now, to understand this technical term, we are going to look at the processes in a very open manner. So first, we are going to look at oxidation processes, and then we also look at reduction processes, and then we look at what happens under oxidation processes, and then what happens under reduction processes, so that we're able to understand redox reaction the best. So we are going to look at one. Oxidation reaction. 2. Reduction reaction. Quickly, I'll pick oxidation reaction so that we open up and then we understand it the better. So we have oxidation reaction. To understand oxidation reaction, we will look at oxidation reaction in certain terms. We want to understand oxidation reaction or oxidation processes. Then you have to look at it in terms so you'll be able to understand oxidation processes. We are going to look at the first one, the first term, that is in terms of elements. In terms of elements. Now, if you look at the word oxidation, the root word is oxygen. If you look at oxidation, the root word is oxygen. So if the root word is oxygen, then I'm going to begin with the first element, which is oxygen. So oxidation. Oxidation is a reaction in which oxygen is chemically combined with a substance, or somebody can say the chemical combination of oxygen with a substance. The chemical combination of oxygen with a substance. In simple put, you can say addition of oxygen. Addition of oxygen. So addition of oxygen. Now let's look at some examples. I have carbon plus oxygen will produce CO2. Another example, sulfur plus oxygen to produce SO2. So we have a very simple example or examples. That is carbon reacting with oxygen produce carbon dioxide, and then we also have sulfur to produce SO2. Now, what happens? Let's look at some simple explanation over here. Since So that is a very simple explanation. Since oxygen has been added to both C and S, that is carbon and then sulfur, then oxidation has taken place in both C and S. Therefore, both C and S are said to be oxidized. So oxidation has taken place in both C and then S. Now that is in terms of oxygen. That is in terms of oxygen. Now let's look at it in terms of hydrogen. So in terms of hydrogen, that is the removal of hydrogen from a substance. In terms of hydrogen, it is the removal of hydrogen from a substance. Now, we are going to also look at a very simple example. When you remove hydrogen from a substance, then that process is also termed as oxidation process. So hydrogen will be removed from H2S and then will be added to chlorine to form hydrochloric acid, and then sulfur will be displaced in that form. Now, when you look at this reaction, the process is not balanced. Hydrogen is 2 and then hydrogen is 1 over here. So put 2 there. Now chlorine is 2. So it means that chlorine must also exist as diatomic molecule. So we have hydrogen balanced, chlorine 2, and then that chlorine is also 2 over here. So look, if you look at the process scheme, you can see that hydrogen was taken from sulfur and then was added to chlorine to form hydrochloric acid. Now that is also a process of oxidation. The removal of hydrogen from a substance is a process we term as oxidation. Now we are also going to look at the last process, that is loss of electrons. So if you have a process where we have loss of electrons, then it means that chemically that means oxidation has taken place. So the third one is loss of electrons. So loss of electrons. With this, I'm going to explain with some technicalities so that you'll be able to understand the process the best. In fact, in most of our reactions, we are going to look at loss of electrons and gain of electrons. That is what mostly occupy the whole topic that we are going to consider. So here, I'll give you some technicalities as to how to resolve to the loss of electrons so that you'll be able to have upper hand on that. But for the rest of the processes, they are very, very simple to determine that. So loss of electrons. I'll pick the first example. The first example, which is zinc. Pick zinc to produce Zn2 plus lots of electrons. In fact, for me to balance it, then I have to add electron to this side. But looking at it, over here we have 0. We have 0. So it means that I have to put 2 there so that the process becomes balanced. Now this process, this reaction indicates loss of electrons. So you can see that we have zinc lost 2 electrons. Now we can also talk of Pb. So we have Pb 2 plus and then E, then I'll balance with 2 electrons, so that this place becomes 0, that place also becomes 0. So the equation is balanced. Now looking at what has happened over here, we can see clearly that there has been loss of what? Electrons from lead and then what? Zinc. Now this is the technical thing we are supposed to know. When we talk about loss of electrons, which is an oxidation process, we always add electrons to the, if you look at it, if I'm supposed to face you, then it means that we add electrons to the left hand side. But if I'm facing the board, then it means we will add electron to the right hand side. So we add electron to the right hand side if you are facing your book. So if you are facing your book to the right hand side of your book or any paper, that is where we add the electron. And when you add electron to the right hand side of your equation, then it means that oxidation has taken place. Oxidation has taken place. In fact, we can represent these 2 equations also in another form so that you don't get yourself confused. Let's look at it. We can look at Zn minus 2E. So it means that to say oxidation has taken place, that is when we subtract electron from the left hand side of the equation, then it means that oxidation has taken place. So to produce Zn2 plus. And then we also have Pb minus 2E to produce Pb2 plus. You can see that the equation can also be in this form. This also indicates loss of electrons. So it means that zinc lost 2 electrons to become Zn2 plus. Pb lost 2 electrons to become what? Pb2 plus. When it happens this way, the equation is balanced. And then all these processes explains loss of electrons, which explains what? Oxidation reaction, which also talks about the process of what? Oxidation. Now we are going to look at the last process, which is reduction. The last process, which is reduction. So we are going to look at reduction reaction. And that one, to look at it in terms of elements. So reduction, 1. I want to put it in a very simple term. Addition of hydrogen. Addition of hydrogen. So the chemical combination of hydrogen to a substance is what we term as reduction. So if you chemically add hydrogen to any substance, it means that reduction has taken place. Now a very simple example. First, remember I said for the definition for reduction reaction, addition of hydrogen in a simple term, or the chemical combination of hydrogen to a substance. So let's look at what will happen in this process. So we have Cl2 chlorine plus H2S hydrogen sulfide. The reaction. So you see that in this manner hydrogen was added to chlorine to form hydrochloric acid. So let's balance the equation to form hydrochloric acid. In this manner we have added hydrogen to this substance. We have added hydrogen to chlorine. So here since since hydrogen has been added to chlorine, then reduction has taken place in chlorine. Therefore, chlorine is said to be reduced or is said to reduce. So, in fact, we have seen the first process, which is addition of what? Hydrogen. And then we are going to look at the second process. We are going to look at the second process. So I want to drink or two. Removal of oxygen from a substance. Removal of oxygen from a substance. Let's look at a very typical example. So you can see that here oxygen has been removed from manganese to produce manganese with a charge 2+. Now we have to balance the equation. To balance the equation, to the side lacking oxygen, we add water molecules. So I'll add water molecules to this side, and then to the side which is not lacking oxygen, we will add hydrogen ions. Add hydrogen ions. Now, in fact, we have to balance the number of atoms for the various elements. Oxygen is 2 over here, manganese is complete, but oxygen is 2 over here. Here, from the product side or on the product side, oxygen is 1. So, which means I have to put 2 there so that oxygen becomes balanced. In balancing oxygen, I have increased the molecules of hydrogen. So, hydrogen has become 4. Therefore, I'll put 4 over here. So the equation is now balanced. Now, what can we say concerning this equation? Since So that is the nice explanation there. Since O2, oxygen has been removed from MnO2 to become Mn2 plus, then reduction has taken place in MnO2. Therefore, MnO2 is said to be reduced. So that is reduction which has taken place in MnO2. So that is another way of describing the process of what? Reduction. That is the removal of oxygen from a substance. The next one too is the third point under the process of reduction, which is gain of electrons. Okay. Gain of electrons. Gain of electrons. Here I will explain some technicalities as I did in the explanation under the laws of the electrons under the oxidation. So this one to explain some technicalities as to how to identify the site which has gained electrons and therefore undergone reduction, and then the site which has also lost electrons and therefore has undergone oxidation. So here too I will explain some technicalities over here as to how to determine the site that has gained the electrons, and then so on. So let's look at some simple examples under that. We have read Pb2 plus gain. So it gained 2 electrons to become Pb. Another example too is zinc. Zinc2 also gained 2 electrons to produce zinc in this manner. Now, under the gain of the electrons, there is one thing specific over here. We add electron to the left-hand side of the equation. We add electron to the left-hand side of the equation for the gain of electron. So you can see that I added electrons to the left-hand side of the equation. This is the left-hand side of the equation. This is the right-hand side of the equation. So under reduction, in reduction, we add electron to the left-hand side of the equation. So in reduction, we add electron to the left-hand side of the equation. This equation or this equation can also be written in this form. You can write it in this form, or you can say Pb2 plus produces Pb and then minus 2e. And then you can also look at Zn2 plus to produce Zn2 minus. So this process also illustrates the gain of what? Of electrons. So that is a typical example of that. Now we have looked at the 3 ways as to how to explain the reduction process, and then we have been able to make a very simple conclusions under that. Now the summary of the redox reaction, the first part of the redox reaction. So, in summary, we have come to understand that we have 2 processes that takes place in redox reaction. So, and then this process occurs simultaneously. We said 2 processes, it occurs simultaneously. So, redox. We have oxidation, and then we have reduction. So oxidation process, and then reduction process. These 2 processes, we have said that it occurs simultaneously. So that means it occurs at the same time. Simultaneously means it occurs at the same time. So we have come to look at oxidation process, we have looked at reduction process, which occurs at the same time. So when you pick, let's pick oxidation. Oxidation reaction. one happens an oxidation reaction. One, that is addition of oxygen, removal of hydrogen, and then loss of electrons. So oxidation, we said, is addition of oxygen, removal of hydrogen, loss of electrons. Now reduction. So reduction reaction. Reduction reaction, we said, is addition of hydrogen, removal of oxygen, and then gain of electrons. Now, under the loss of electrons, note always electron or electron is added to the right hand side of the equation. So always electron or electrons is or are added to the right hand side of the equation. So always electron or electrons is or are added to the right hand side of the equation, and that indicates that the process is what? Is oxidation. So you know this process is oxidation, right? So to indicate the process of oxidation. So this will help us indicate that this process is oxidation. So for example, we have Cu to produce Cu2 plus B, that. So this indicates that oxidation has taken place. So oxidation has taken place in C. So this means this means Cu has lost 2 electrons to become Cu2 plus. Therefore, oxidation has taken place in Cu. So that is what it means. Now let's also look at another note. You see that I added electron to the right hand side of the equation. This is the right hand side of the equation. And I added electron to the right hand side of the equation, indicating that copper lost 2 electrons. Now let's also look at this gain. Gain of electron or electrons. Always. So electron is added to the left hand side of the equation to indicate gain of electrons. So electron or electrons are added to the left hand side of the equation to indicate gain of electron or electrons, gain of electron or electrons. So this is a typical way of describing the process we call reduction. So this indicates that there is a gain of electrons and therefore reduction has taken place, So this is to also explain reduction process. So that is generally to explain reduction process. So let's look at a very typical example, and that we can pick. Let's pick Fe3 plus. I know I'll add electron to this side to produce Fe. So to produce Fe, I'll put 3 over here. This indicates that iron gain 3 electrons to produce Fe, that is iron, normal iron. Now, today we have come to study redox reaction. That is the first part of redox reaction, or the introductory part of redox reaction. We have been able to know that when we talk about redox reaction, we are talking about two processes which occur simultaneously, which is oxidation processes and then reduction processes. And we said it occurs simultaneously, which indicates that it occurs at the same time. Now we have talked about oxidation reaction, which says that it's addition of oxygen, removal of hydrogen, and the loss of what? Electrons. We have also talked about reduction processes or reduction reaction, which also talks about addition of hydrogen and the removal of oxygen and then gain of what? Electrons. I have told you, or we have said, or we have discussed that when we are talking about loss of electrons, it means when you add electron to the right hand side of the equation, that indicates that such element or such compound has what? Lost electron, and such element or such compound has undergone the process we call oxidation, or has undergone oxidation reaction. Now, to also look at the gain of electrons, I've also said when you add electron to the left hand side of the equation, that also depicts or indicates that such element over there, such compound over there has what? Also undergone the process we call reduction. That is technically what you have come to discuss today. That is technically what you have come to study today. In my next tutorial, we'll be discussing the concept of oxidizing agents and then the concept of what? Reducing agent. Here or over there, we'll be discussing how to identify oxidizing agent, how to also identify reducing agent in my next tutorial. Now, we have come to the end of the first section of redox reaction. Thank you for watching, and you are welcome to Chemistry Made Simple. Bye.